So in the last lecture, we discussed about the various type of attacks. Okay. So in that attacks, I explained you how the various different type of threats, vulnerabilities, attacks like passive attack, active attacks. Okay. Now today we will discuss some of the layer 2 attacks. Again, this is very simple topic, I know, but still this is also an important topic. So when we talk about layer 2, it actually immediately reminds us about the switches, because switches works on data link layer. Okay, I'm talking about the L2 switches. Okay, so when we talk about L2 switches, you have different type of, or you can say common type of L2 attacks also. So the first type of attack, which is DHCP spoof attack. Like, now the term spoof means what? Fooling. Hello, 1 minute. Huh? Who's writing what? One minute. Yeah, I'm recording this session, Mohammed. Okay, you can see there's a red dot here. So recording is started. Okay, and I'll send you both the recording today after finishing the lecture. Yesterday's last lecture's recording and today's recording.
Okay, thank you.
Yeah, welcome. So when we talk about spoof or spoofing means like, fooling, like somebody's trying to manipulate, somebody's trying to, fool out somebody. Initially, when we talk about DHCP, it's very simple protocol, dynamic host configuration protocol. It is really a boon to all the network engineers, because earlier it was bootp, and before that everything has to be done manually, writing down the IP addresses on each and every node. Afterwards, they came out with bootp program. Bootp was having some drawbacks. So the successor for bootp was DHCP. So initially when we studied DHCP in CCIE, we studied that this fellow is going to help us give the IP addresses automatically to the nodes. So the working is also very simple, like discover, offer, request, and acknowledge. Discover, offer, request, and acknowledge. That is DORA. Nobody thought nobody ever thought that this DHCP can be, somebody might attack this DHCP also. See, basically the attacker is in LAN. Many times students get confused that how come the attacker is LAN. So I told you last time also, we have disgruntled employees. Now these employees are not happy with the salary, not happy with the boss behavior, not happy with the company. And I told you last time that some people are born with that mentality, that they don't want something running smoothly. They want to harm it. I told you an example of a kid. You give him toys, he will break it. He is having fun in breaking those toys rather than playing with those toys. Okay. So same way, there are people in your own company. Like I remember many times the printer papers are gone. Like, somebody is stealing those papers also. When you go to print out, when you go to take some printout, papers are not there. The peon is telling me, yesterday only I just loaded one full bundle of papers. I don't know where the papers are gone. No doubt, people might be taking printouts. But then we found out that one of the employees is always carrying those papers home, robbing. Like, it's a small theft. But yes, then we asked him, why you're doing like that? Just to, my kids want to write some notes, so I take this. So this is not good, or this is not okay. You cannot take even a pencil of your office to home. It's a theft. Okay, whatever pencil, whatever pen, whatever eraser you're getting, it is for office use only. You can't take it home. Like many times people take staplers, pencil, pens home. So these kind of people are definitely, no doubt, security is there for checking all those stuff, but like many times they don't check employees for all these kind of small things. But we are talking about disgruntled employees who are really, trying to make things worst for the company, and company always uh, don't trust even the LAN users. So DHCP spoof attack is also one of them. One of the ways an attacker can gain access to the network traffic is to spoof responses that would be sent via a valid DHCP server. So always remember, a DHCP server is there and a DHCP client is there. Client are asking for a valid IP addresses from the DHCP server, and DHCP server is giving them after a communication like discover, offer, request, and acknowledge. The DHCP spoofing devices reply to the client DHCP request. Now, the intention of the attacker is to fool, or the intention of the attacker or the rogue device is to give a fake pool of IP addresses to the LAN users. Now, this is a kind of a man in the middle attack. So this is your attacker who is trying to give some kind of fake IP addresses which is not part of your legitimate pool. This is your legitimate server with a legitimate pool of IP addresses. We call it pool. The reason for giving this IP addresses to the LAN user is to do man in the middle attack. Because see, if your normal non-IT clients, I'm talking about people who are accountants, HR, marketing people, these are all non-IT people. No, they don't understand what is the meaning of IP address, subnet mask, default gateway. They don't know. They just want the first thing when they come in the morning, switch on the PC, give the username, that is the pin or whatever password to their PC, and they want internet to be running on their PC. If internet is not running, they'll start screaming the IT guy, hey, the network support guy is going to come and resolve their issue. So the motto of normal workers or non-IT workers is to get internet on their machine. And to get internet on their machine, they want a smooth running, like, they don't want anything mess up. But they don't have any idea, like, what is going on. And this attacker is trying to send a fake IP address or a fake gateway. So what happens when they reply or when they try to send some important document, it is actually being received by the attacker who is sending them his own IP as a gateway. So all the traffic, instead of going to the legitimate gateway, that is the router or a firewall, it immediately goes to the fake DHCP server, or you can see the fake DHCP or rogue DHCP gateway or the gateway. Now this is really, they also don't know. And what this guy will do, he will immediately NAT whatever IP he has given for these guys, NAT it with the legitimate pool and send it to the gateway. Okay. So this fellow might use two LAN card. Okay. He might create his own PC as a DHCP server, that is illegitimate DHCP server, create a pool which is not belonging to the legitimate pool, that is the genuine pool, and start giving these IP addresses to these machines, and then finally NAT this IP address with the legitimate pool and send them on internet. So what happens, these people will never come to know that internet is coming through some proxy, or internet is being received through some illegitimate DHCP server or attacker. This kind of attack is called what? DHCP spoof attack. This fellow as a DHCP client is shouting. See, always remember, when you make a machine DHCP client, he doesn't know, he don't know who is his DHCP server. He always send what? A broadcast, discover broadcast. It is in the form of broadcast. And this broadcast, see, discover broadcast. Discover messages are being sent. It's a broadcast. Okay. Now this broadcast is being received by all the nodes in the LAN as it's called as what, discover messages. And offer can be done by anyone who receives the broadcast. We can do offer, but initially what happened, who does the offer? It is the legitimate DHCP server that do the offer. But you can see that legitimate DHCP server is not located here, because this company is following an hierarchy. In switching we have a hierarchy, which we call it 3-tier hierarchy. What is that? Core switches, distribution switches, and access layer switches. No doubt we nowadays follow spine leaf architecture, where we have a kind of a collapse core architecture, where you have only spine and leaf. But initially when this attack used to take place, and see, this spine leaf architecture is not followed by every company, it is followed by the data centers mostly. So if the company is following this architecture, or you can say this hierarchy architecture of switching, that is 3-tier hierarchy, they are having their core layer switches, they are having distribution layer switches, they are having access layer switches. Always remember, server farm is somewhere above core, behind firewall, in demilitarized zone. So there is a chance that this discover messages might reach this legitimate server a little bit late. But just because this node, which is very next in the access layer itself, access layer switch itself, he will receive the information very fast, and he can immediately respond to this discover message, and that message is called offer messages. So when you do obtain an IP, automatically you are anywhere, you're not mentioning anywhere that who is your DHCP server. So they don't know who is the DHCP server. So server offer IP addresses. If it is genuine, he will offer. But if it is fake server can immediately offer. And these people, they don't know. They will immediately, they're IP hungry. See, he's telling, I need an IP address, subnet mask, default gateway, and DNS server. This message is being broadcast, or this discover message is being broadcast on all the nodes, because my switch also don't know who is the DHCP server. So switch always do what? Whenever he receives a discover messages or broadcast on an interface or on a port, he will always forward it on all the other port except the port from where he has received the message. So what happens if there is a fake server? Here you go, I might be the first to give you the IP address. Now what happens, he got the IP address, so he won't take it from the legitimate server. He said, oh, my requirement is fulfilled now. But what is the problem now? He got the fake IP addresses from the fake server, and his packets are being diverted to the fake server. This is called spoof attacks, DHCP spoofing attack or spoof attack. Now when they found out that these kind of attacks are being taking place in the layer 2 environment, that is in switch environment, on access layer switches, this kind of attacks are taking place on access layer switches, they immediately said we can mitigate those attacks by doing what? DHCP snooping. Now see, the attack name is spoofing, and the mitigation technique or the mitigation of this attack is done through DHCP snooping. Snooping is nothing but listening silently, or you can say eavesdrop. So now the switch is a little bit, now the switch is very intelligent. Now he is active. He said, boss, it is really bad that being a switch, I am not able to find out that there is an attack, which is called man in the middle attack, because this fellow attacker want to sniff into all the packets which are being sent by these users. How? By giving them his own IP address as a gateway, and he can find out all the packets, he can sniff all those packets. So DHCP snooping is a Cisco catalyst feature that determines which switch ports can respond to the DHCP request. So what he does, immediately converts all the access layer ports, Remember, when you configure DHCP snooping on a switch, which switch? Access layer switches, not on distribution, not on core. No need to do anything. You don't have to do anything on this, because this attack take place on access layer switches. So the mitigation also has to be done on access layer. As soon as you configure DHCP snooping, immediately DHCP snooping converts all the ports as what? Untrusted. Now what is the meaning of untrusted? Untrusted means I'm going to allow only discover messages from these ports. You are allowed, you are entitled. But you are not allowed to offer. You are allowed to request, but you are not allowed to acknowledge. Because I told you in DHCP you have discover messages, you have offer messages, you have request messages, and you have acknowledge. Discover messages are always towards server. Offer messages are always towards clients. Request messages are always towards server. Acknowledgement are always towards clients. Who can do offer? Only server. Which server? Legitimate server. Where is the server? Definitely server cannot be on the access layer switches. Server is in server farm. Server is behind firewalls DMZ, that is demilitarized zone. So server is far off, and only these messages, that is offer messages and acknowledge messages, can come on only trusted ports. That means you see in this diagram, these ports are converted into trusted port. Why? Because these are the trunk ports facing distribution layer switches, and then distribution layer facing core switches. So offer messages and acknowledge messages can be received only on trust ports, and you have already configured these trunk ports as trust port, and you have already by default these ports are converted into untrusted when you configure DHCP snooping. So what happens if this guy again telling I am looking for an IP address, subnet mask, default gateway, and DNS. If this attacker is trying to offer him, he is offering through untrusted port. This is an untrusted port. I will block this DHCP offer. Till that time, the legitimate DHCP server is already offering him the IP address. So he, instead of taking from this guy, he is already taking it from the legitimate DHCP server. So at least the fake server is not able to give him the fake IP addresses from the fake pool. Okay. How can you, what is the configuration now? The configuration is simple. You have to go in the global configuration mode and you have to say IP DHCP snooping. Now this is a global configuration. That means suppose if this switch is a 48 port switch, all the 48 port will be activated for DHCP snooping. That means all the 48 port will be now converted into what? Untrusted. With just one command, you actually enables DHCP snooping globally on a switch. Now what happens once you enable DHCP snooping globally on a switch? You have to go manually and configure truss on the trunk ports. Why? Because suppose this is your access layer switches which is connected to distribution layer switches. So this has to be definitely, this will be trunk, ether channel, whatever is configured. So this switches now will be configured for truss. That means these ports will be configured for trunk. This port, this port, this port, and this port. Okay. Why? Because these ports are going towards the distribution layer switches. That means I want all the discover messages to go on like that towards the legitimate server. So I'm going to make this port as what? Trust. I'm going to make this port as what? Trust. How to configure that? You have to go on the interface and say IP DHCP snooping trust. So this is your mandatory command. This is your mandatory command for configuring DHCP snooping. In your lab, you will be definitely asked in some section for configuring DHCP snooping. They won't tell you to configure DHCP snooping. There will be an hidden sentence, like sentence pointing out towards DHCP snooping. Okay, they'll say that they don't want spoof attack, or they'll tell you that they don't want any illegitimate or rogue server should offer IP addresses, subnet mask, default gateway to the authorized nodes or LAN users. See that you configure mitigation of these kind of attacks possible. So now how to configure? First command is this. Second command, you can do this. This is again an optional command. If they are telling you that they want to limit the number of packets per second on a port, because see, this rogue or this illegitimate server might go on sending offer messages on these ports. So you don't want these kind of disturbance on these ports. So you can limit, because offering can be received on the trunk ports. Offering will not be received on the access ports. So you're trying to limit the number of packets per second on a particular port. You don't want the illegitimate server to go on offer. Okay. So you can just limit the rate, number of packets per second on a particular, not on a particular port. You can say it on all the ports. So that is why it's a global configuration, but optional command. If you don't give, it's okay. IP DHCP snooping VLAN number. Now this is again important. See, you enable DHCP snooping globally, that is okay. Now you have to enable DHCP snooping on a particular VLAN or a range of VLANs. Okay. So if you don't have VLANs, at least you activate on VLAN 1. At least you can activate on VLAN 1. Okay. Now, what is this command? IP DHCP snooping information option. Now this is like normally you have various options available. DHCP option numbers are available. So this is actually by default activated on the switch. What is this actually command designed for? Okay, and this command is already activated. You don't have to give this command. But suppose somebody deactivate this command, then you have to give this command. Otherwise, you don't have to use this command. Okay. According to this command, what exactly is this command? 1 minute, somebody is writing something. Okay, so Kekana is asking, is it mandatory to perform DHCP snooping command on ports and VLANs? Yes, I told you, no. This global command is also compulsory and VLAN command is also compulsory. These two commands are compulsory. That means you have to activate globally also on the switch, and you also have to activate on a particular VLANs. But you are telling me like you don't have VLAN. Suppose you don't have VLAN, then at least specify VLAN 1. But you are telling me, no sir, we are having a lot of VLAN. So you can give a range also, like VLAN 1 to, like how many VLANs you are having? We are having 1000 VLANs. So you can say from 1 to 1000 allowed. So this command is important. This command is important. This command is important. Clear?
I have one query.
Yeah.
Hello.
Yeah.
Suppose my DHCP server, which is in VLAN 100. So is it okay to configure like IP DHCP swooping VLAN number is 100 on that particular interfaces?
Yes.
So that will work.
Yeah. I told you, it has to be activated on all the VLANs. Okay.
Okay.
See, basically your server VLAN is 100, right?
Right.
But
Right.
server is not on the access layer switches. Server is
Right.
somewhere else. It is
Right.
behind core.
Right.
See, the attacker is sitting in the LAN where,
Right.
see, try to understand the hierarchy. Users
Okay.
always are, we call it edge nodes, no? End users. End
Right.
user are always connected on the access layer switches. According to Cisco's 3-tier hierarchy, users always get connected to access layer. So user means that attacker is also a user, no? Okay, so where
Right.
he is connected, he is connected to access layer switches. So we are trying to configure this mitigation or snooping only on access layer. We are not bothered about distribution and core. But somebody is thinking like, that means distribution and core is left like that. So if the attacker is connected to distribution, then you are making a mistake. How can you make a person's connect in the distribution layer switch? That means you are telling me, sir, whatever my boss do dealing, okay, the employee should not know, right? So that is why boss is sitting in the cabin and doing those dealings, no? And cabin is locked. If you want to go also, you have to knock the door. So he said, no sir, the person is also sitting with boss, then no one can help you, no? If the user is also sitting with boss and he is listening all his conversation, then you will come to know. So if you are adding a user to the distribution or core switches, then nobody will help you, no? You have to do the configuration on access layer, because the attacker is also on access layer and the user is also on the access layer, and you have to definitely trust those connection, that is those trunk links which are going on the distribution and core. So you don't have to configure anything on distribution and core also. You have to just configure the trust port on the access layer, because those are the trunk ports. Okay. And definitely it is not going to make sense like if you configure it on VLAN 100 also, because it is on access layer only, no? And access layer you don't have server. The server is in core. Okay. And you are definitely allowing those messages because you are making this link trunk. That means all the legitimate server can easily send these offer messages on trunk link because they are all trusted. Got it? Okay.
Yes. Yes.
Yeah. And why this command has they have given? Because this command is actually activated. You don't have to do anything. What is this command meant for? Anyone? IP DHCP snooping information option. My switch is acting like a relay agent. See, initially my switch was not participating in this kind of activity. Like user are asking IP address and switch is telling, sorry boss, I don't know who is going to give you IP address. I'm going to forward your broadcast to all the other switches on all the ports. Let the DHCP server hear about that and let him do what he wants. I am not at all bothered. I am a switchman. I am a centralized device making you and your server communicate. That's all. I don't know what is DHCP. I don't know how you're communicating, whether he is giving you IP address or not. I am not bothered. Okay. Like you have RA nowadays in IPv6, router solicitation messages and router, like in DHCP, sorry, in IPv6, we have Slack, SLAAC, that is auto configuration of the users. That time also my switch is like my routers are participating in this DHCP activity, though they are not DHCP. Okay, so we'll discuss that in RA guard. Okay, how Slack works and how this mitigation technique works. So this information option means like now my switch is really bothered about the attacks. Why? Because of DHCP snooping. Now DHCP snooping is telling him, boss, you have to pay attention all these activities. You don't know there is an attack going on, DHCP spoof attack. So switch is very much ashamed, you can say, in normal general terms. He is ashamed. Sir, because of me the attack took place. So you have to be careful. So what he's going to do, he is going to take the request from all the users, send this frame to the DHCP server in the form, initially it will be in the broadcast format, okay, and in that frame he is going to fix his own MAC addresses. So when the request goes to the DHCP server, legitimate DHCP server, he returns this frame to whom? To the switch, because his MAC address is there. It's like an encapsulation. It's like something is getting stick on the frames, the request frames. And whose MAC address is there? Switch MAC address. So switch receives that frame first. Okay. And when the switch receives the frame first, he can find out, like for example, if my son want to order some toys from Amazon, he will never write his name, he will write my name in the address, like dad's name. So what will happen, the courier boy will come, say who is Munawar Khan, then I'll say yes, I am the person, so this is your courier. So when I receive the courier, I will open it and I will find out what is there inside this, and then I will come to know that my son has ordered some toys for him. Nowadays kids are very intelligent, they know that dad's credit card or debit card is attached with Amazon, so they can order also. Definitely he might ask me in the office, dad, I am ordering some toys, okay, with your card attached to that Amazon account. So I said okay. So when the toy comes in, I see what is it, and then I give it to my son, I receive it and I give it to my son. So what happened, I know what he is ordering now, because the courier is coming with my name. So when I receive that courier, I open it and find out what is being ordered. Okay. So what happened now? Switches are now becoming intelligent. They are maintaining a table now. What is that table called? DHCP snooping information table. Okay. What is there inside that table? They actually keep the record of all the IP addresses. Okay, DHCP snooping table carries the information of all the IP addresses, all the interfaces, you can say. Okay, they are keeping the tab of all the interfaces. You can see a DHCP binding table. That is not normal binding table. See, normal binding table is built by the legitimate DHCP server, but access layer switches are maintaining snooping binding table. So this is nothing but snooping binding table. Who is maintaining this? Access layer switches, where you have configured DHCP snooping. Actual binding table is maintained by the DHCP server, that he allocated this IP address to so and so MAC address with so and so lease. So this DHCP snooping binding table is being saved by, or you can say maintained by, access layer switches, where you have configured DHCP snooping. And see what he is maintaining. He is maintaining MAC address, he is maintaining IP address, he is maintaining lease time, he is maintaining binding type, he is maintaining VLAN number and port ID and all, because it is possible that you will be having multiple VLANs with multiple different subnets and multiple pools to offer. Like VLAN 10 might have a pool of 192.168.10.0/24. VLAN 11 will have 192.168.11.0. VLAN 12 will have 192.168.12.0. So according to their subnet, according to their pool, they'll be offered the IP addresses. No, so this guy is going to maintain everything: VLAN ID, port ID, MAC ID, IP address, lease time, everything. Okay, like for example, I appointed one agent. I asked my agent, can you make a passport for me? I don't have time. So agent said, okay, I will charge you 500 rupees, okay, or some dollar as a fees or as a extra charges. I said, okay man, take, but I don't have time, you make my passport. So what earlier, I'm talking about few years earlier, we used to do the same thing. So what we have to do, he will bring the form, he will do all the needful, he will fill the form looking at your certificates, and then he will also ask for original certificates. So when I'm making a passport, I have to give all original certificates to him. So he will check my all original certificate, like school leaving certificate, college certificate, my mark sheet, my my university certificate. In fact, if I'm married, he will also see the marriage certificate. Wow. So he will come to know when I got married, whether I am single or married. He will come to know what is my age, because every item I have to give him is original. So he can make a Xerox copy also. So I have to be very much sure that he is the trusted person, agent. He will he will take a Xerox copy, or he will take a photocopy of my original, and he will give it to the passport office, and he will make a good passport and give it to me. Everything is handled by him. I don't have any headache. I will pay him the charges. But remember one thing, I am giving him all the originals. And then he will return me back, no problem. But he has come to know all my details. So same way, all the PCs are going to send their information to the switch, and switch is going to maintain a table because you configured DHCP snooping. See, earlier he was not doing anything. He don't know what is DHCP. Now he knows what is this. Okay. So trusted port can source all the DHCP messages. Untrusted port, if a rogue device on an untrusted port attempts to send something, okay, untrusted port are those not explicitly configured as trusted. By default, all the ports are untrusted. So DHCP information option is nothing but taking an extra pain of receiving those discover messages, forwarding it on the trust port. When it is being received, opening it, those envelopes, finding out the IP addresses to be given on a particular port, writing down the port numbers, writing down the VLAN IDs of that particular users, writing down the lease time, writing down every detail of that particular port. Earlier he is maintaining only port number and MAC address. That's all. When you say show MAC address table dynamic, you can see all the MAC addresses learned dynamically by the switch. So what you can see, only port ID and MAC address. But in DHCP snooping binding table, you can see everything. He is maintaining the information. Got it? So this is optional command. You don't have to give. It's okay. You don't have to give this also. But anybody disable this by giving no IP DHCP, then you have to enable it. Otherwise, you don't have to give. It's already enabled. Clear? When you say show IP DHCP snooping, you can see DHCP snooping is enabled. DHCP snooping is configured on following VLANs. So somebody was asking me whether it is necessary. Yes, see, you can see DHCP snooping is configured on following VLANs. You can specify VLAN, you can specify the range of VLANs. You can see if these ports are trusted. No, that means these are access port. This port is trusted, yes, because it's a trunk port and it is having an unlimited rate limit of packets per second, PPS. See, by default the feature is not enabled, so you have to do this. This is optional for forwarded DHCP request packet to contain information on the switch port where it is originated. At least one trusted port must be configured. Use the no keyword to revert to untrusted. By default, all ports are untrusted. At least one. Otherwise, your request will not reach the legitimate DHCP server and you will not get the IP addresses. Configure the number of DHCP PPS that an interface can receive. Normally, the rate limit applies to untrusted interfaces. Yes, because you want to limit, because that also can be one attack where the illegitimate server continuously sending packets on that port, disturbing the switch. So you can even limit it. This is used to prevent DHCP starvation attack by limiting the rate of the DHCP request on. See, DHCP starvation attack. Continuously somebody is asking for IP addresses. You don't want somebody continuously asking and utilizing all those IP addresses. Possible, it's a fake request being sent by the user, illegitimate user, and making a DHCP starvation attack. DHCP starvation means all the genuine IP addresses being utilized by the fake user, so that the genuine user is not able to get the IP addresses because it is finished now. The pool is empty. So all the genuine users will not get the IP address. So That is called DHCP starvation attack, and they don't want DHCP starvation attack to take place, so you can do this command. Again, optional, it is not necessary. You want to mitigate, then only you do. Enable DHCP, this is required. See, this is required to identify those VLAN that will be subject to DHCPs, verify the configuration. Clear, all of you? All of you, DHCP snooping. Next is IP snooping. Now, again, sorry, IP spoofing, not snooping. DHCP spoofing and then IP spoofing. IP spoofing means taking somebody else's IP addresses and sending an attack or attacking. So what will happen? The logs will capture the IP address, and log will immediately alert that this IP is trying to do some mischief. Like for example, if my phone is getting hacked, and that hacker might send messages to my contacts, some bad messages. So who's going to get blamed? I only. People will call me and give me bad words. What? Why are you sending these kind of messages to us, man? Why your mail account is sending us viruses? I remember few years back, all my friends started calling me. Why your mail is infected with viruses? They are asking me to open this link and we getting infected. I said, I never sent you any mail. They said, no, your mail account is sending us this kind of mails and it is purely infected. The mail is telling us to click this link. You have a beautiful photo. We thought you are sending beautiful photo. So I said, no, I didn't send you any photo. They said, no, all our mails are now problem like. So IP spoofing is something where a host is assigned an IP address and expected to see. Initially, a host is assigned an IP address and expected to use that address in all the traffic. IP addresses are effectively used on the honor system where hosts are trusted. Definitely, I got an IP address of 192.168.10.2. So I have to use this as a source. In all my packets, I will use this only because I got this from the DHCP server automatically. When I got it, one day before. What is the least time? Say 6 months, or say 1 month, or say 48 hours, whatever. So 48 hours, this IP will be with me, or if it is 8 days, according to Microsoft, it is 8 days. So all the 8 days, this IP will be with me. So whenever I send the packet, it has to be this IP as a source, because this is the IP I belong to. But now what happened? Illegitimate user is trying to send packets with this source. Suppose this fellow has not come to office today, so he has already, see, this is an attack. So don't ask me how this take place. This fellow is an attacker. He is using various tools to spoof those IP addresses. Spoofing means what? He know that this guy is having this IP addresses, so he spoofed it, and he is now using these IP addresses to send the packet, rogue packets, fake packets. Okay. So you don't want any attacker to use your, like for example, I give a call and specify some name. Okay, my neighbor's name. So people will always catch my neighbor because I specified his name. So a rogue or a compromised host PC doesn't necessarily play by those rules. It can use a legitimate address, or it can begin to use spoof addresses borrowed from other hosts or use at random. Spoof addresses are often used to disguise the original DOS attacks. If the source address doesn't really exist, no return traffic will find its way. No doubt, this fellow might be sending some viruses to the server, and he knows that 10.2 is having a lot of privileges. Manager's machine or VP's machine. So what he will do, he will use that same IP address as a source, and he will try to send viruses to the server. He might get privilege to access that server because he belongs to 10.2, and he might send attacks to that server. He don't want the return packet. His job is done. So IP spoofing is an attack where somebody is trying to borrow some legitimate user's IP address and send an attack. Okay. Like for example, I remember one incident occurred that somebody wanted to give some money, like some course fees. So he went to that institute and he said, somebody, Mr. Alex, called me this morning and he told me that you pay the fees because today discount offer is going on. Okay, and I want to register this course. So he personally went to that institute, and when he opened the gate, there was one sofa and one fellow was sitting there. So he immediately asked, Mr. Alex? So he said, yes, what happened? So he said, I wanted to pay fees for this course. You called me and you told me that there is a discount offer going on. So he said, okay, give me. So he gave him the fees. Then he asked him for the receipt. So he said, sorry boss, my printer is not working. So you do one thing, you come tomorrow and you start your course also and you take the receipt also, no problem. So he left. Next morning when he came and he said, I have enrolled for this course and I paid 10,000 rupees. The receptionist said, you gave to whom you gave? So he said, Mr. Alex. Mr. Alex was yesterday on holiday. He said somebody was sitting on sofa. So who was that fellow? Nobody knows. Somebody must have come from outside. He was waiting for some inquiry or something and he took the money and went away. So see, somebody has purposely spoofed the name of Mr. Alex and he took the money, and that is man in the middle attack. So IP spoofing is like taking somebody's IP address, attacking so that he enjoys that same privileges that that machine is using and that IP is using. But now my switch is switch has become very intelligent, because I told him, boss, you have to use one, I told him to I configured IP source guard. What is IP source guard? I told my switch that whenever somebody is sending packet, please check the source also of that packet. That means you try to compare the source IP of that packet. So my switch is telling, okay, I will do it. But the question arises, how the switch will come to know that the packet which is coming on this particular port is carrying the legitimate source IP. Just before this topic, we did DHCP spoof. And when we did DHCP snooping, my switch started maintaining a table. And in that table, he has clearly written that on G0 by 1, this is the IP I gave in the morning from DHCP server. His VLAN ID is 10. His MAC address is so and so. His lease time is so and so. Every detail is maintained in the DHCP snooping table. That means when the person who made passport and now he's getting he's doing a second marriage, and the agent is also a relative of that girl. So agent immediately recognized him. Hey boss, you made passport from me. Remember? He said, yes. But you are married. You gave me marriage certificate also. How come you are marrying second time? That means he is fooling. He must have made his fake profile on the shadi.com or marriage bureau, and he must have specified himself single, and now he's trying to marry a girl. So this agent immediately recognized him. Okay, boss, when you gave me original, so he immediately told the girl's father, okay, this guy is a fake guy, your son-in-law is a fake guy. He said, how come you know? I made his passport. I took all his original. He was carrying a marriage certificate also. I know his name. I know his date of birth. I know his address also. I know his phone number. I only made a passport to him. Anyway, I gathered the documents and gave it to. So I am having a copy also in my office. I can send you now, fax you. See, immediately the guy was caught. So same way, if G0 by 2 try to use the same IP address, my switch will immediately recognize, boss, your IP is 10.3, man. Your VLAN ID is 10. Okay, no problem. But your MAC address is different. I know 10.2 is having a MAC address something else and 10.3 is having something else. How can you become 10.2? Because when you were asking IP address from the legitimate DHCP server, I only offered you, no? I only brought that IP address and gave it to you guys. I have clearly maintained the table with me. I am having the port ID, I am having the VLAN ID, I am having the MAC address, I am having the IP address which I gave it to you, I am having the list type. How can you take 10.2? 10.2 belongs to somebody else, someone else, and he is on port number 1. How can you borrow? How can you take that IP address? So this is possible because of DHCP snooping, but you also have to do IP source guard. IP source guard does this by making use of snip. See, he is using DHCP snooping data. How my switch will come to know that this guy is a fake guy? Because he is purely maintaining the database. Suppose you don't have DHCP server, then you can even write down the static IP addresses with all the details, but nobody will do that. Statically writing down the IP address of all the ports in the binding table, VLAN ID, MAC address, everything, lease time, everything. You can also do that command. If DHCP snooping is configured and enabled, the switch learn the MAC address and IP address of the host that uses DHCP. Packets arriving on the switch port can be tested for one of the following conditions. The source IP address must be identical to the IP address learned by the DHCP snooping or static entry. A dynamic port ACL is used to filter the traffic. The switch automatically creates this access list. The source MAC address must be identical to the MAC address learned on the switch. See this table. This port is an untrusted port. This is an attacker. Is trying to spoof with the help of IP spoofing. So as a source guard, I'm going to check. As a switch, I'm going to check. And for checking this, I'm having the DHCP snooping binding table. DHCP snooping binding table. DHCP binding table is meant by DHCP server, not by the switch. I got an IP address or mask from the DHCP server. Okay, no problem. After you apply IP source guard, now I will pretend I am a different source. I will pretend. What? Who is telling? Attacker. Attacker. I will pretend. Then switch is answering him. Boss, this is untrusted port, first of all. And with the help of source guard, I have checked my binding table, and your source IP address does not match the one you got it from the DHCP server. That is from the DHCP server. So your traffic will be denied. You cannot act as a 10.2 because 10.2 belongs to this guy. Your IP address is 10.5, not 10.2. I will not allow you. If you don't have DHCP server, you can write down manually. But this is again hectic because for every VLAN, every interface, you have to write down this command. IP, source, binding, MAC address of the user, VLAN ID of the user, IP address of the user, interface where it is connected, every detail. So this is not possible. This is used only when you don't have what? DHCP. IP verify source. When you say this command, he will always check the packet source IP address. Port security means he will also check the MAC address now. Not only check the IP address, check also the MAC address. Clear? Optional. Port security is optional. If you want more security, that is why you're doing port security. IP verify source command will inspect the source IP address only. You can add port security keyword to inspect the source MAC address also. Clear? All of you? Show IP verify source. If you need to verify the information contained in the IP source binding database, either learned or statically, you can just give this command, show IP source binding. Okay. So before going for the next topic, ask spoofing, just take a 5 minutes break. I'll just drink water and come. Let's start. The third attack. See, all these spoof attacks are connected with each other, The first mitigation that you did, DHCP snooping connected with IP spoof attack, because here in IP spoof attack also you will be needing DHCP snooping, because the database is maintained in DHCP snooping. The third attack is ARP spoofing. Everybody knows what is ARP, address resolution protocol. In ARP, what happens? User send a ARP broadcast to find out the MAC address of a particular, might be a particular machine or a particular gateway. So suppose in this query, in this ARP broadcast, you see A is trying to find out the MAC address of 10.1.1.1, who is gateway, that is my router. So now router's MAC address is CCC, user's MAC address is AAA, and the attacker MAC address is BBB. So when A try to send a ARP broadcast, this broadcast is being received by the access layer switches in the first place. After that, my access layer switch broadcasts it on all the other port except the port from where he has received the ARP broadcast. So it is being received by the immediate neighbor, might be an attacker on the same switch, access layer switch, before it reaches the router, because router is far. Router is connected to core layer. Attacker is sitting in the access layer. Our broadcast is done by the access layer user. Attacker is very next to him, might be in one of the access layer switches. So broadcast is being traveling from access to distribution and distribution to core, and then goes to router for querying to get the reply. But till that time, this guy immediately sends him reply that yes, I am 10.1.1.1 and this is my MAC address. That means he sends his own MAC address to this guy. So A thinks that 10.1.1.1 is none other than BBB. Actual MAC address is CCC. So instead of this guy replying, this guy immediately replies that this is the MAC address of 10.1.1.1. So what happens? All the frames, all the packets come to this guy. Again, this is also man in the middle attack. So in man in the middle attack, the fake guy, that is the attacker, try to send its own MAC address to the ARP request, making ARP reply, which is again ARP poisoning. It's an ARP poisoning attack, or you can say ARP spoof attack. Okay. In normal ARP operation, a host sends a broadcast to find out the MAC address of a host of a particular IP address. The device at the IP address reply, okay, with its MAC address, normal behavior. The originating host caches the ARP response using to populate the destination. By spoofing an ARP reply from a legitimate device with a gratuitous ARP. Now, you must be knowing about gratuitous ARP. If you don't know, I'll explain you. Gratuitous ARP means any machine that joins the switch, any switch. Okay, gratuitous ARP take place. Gratuitous ARP is used by the host to announce their IP address to the local network and avoid duplicating of IP address. That is why you see when you connect two machines on a switch and you give the same IP address to the second machine, immediately you get a message that your IP address is getting duplicated. How you got this message? Because of gratuitous ARP. Because machine 1 immediately sent a gratuitous ARP telling that my administrator has given me one IP address 192.168.10.2, and if the second machine also keeps the same IP and he do the gratuitous ARP, immediately switch find out that there is a conflict. Okay, and you immediately get a message that this is a conflicting IP address because you guys are on the same. Gratuitous ARP is used by the host to announce their IP address to the local network and avoid duplicating of IP addresses. Routers and other network hardware may use cache information gained from gratuitous ARP. That means anyone can easily find out what is the MAC address or what is the IP address of a particular user through some cache information. Gratuitous ARP is also like a broadcast packet, like an ARP request. What is that in that? Hey everyone, I'm host so and so, and my IP address is so and so, and my MAC address is so and so. So my hacker can easily find out with the like he can hack into the gratuitous ARP. He can easily find out what are the MAC addresses of the machine, what are the IP addresses of the machine, and he can immediately plant one reply to this. So what will happen if this fellow receives the IP address? He will immediately send the packet to this guy instead of sending it to the gateway. But he's smart, huh? He will also give reply to this guy that he is AA. So router is thinking 10.1.1.3 is actually AAAA, but AAA is 10.1.1.2 and not 3. So in its table he has put this entry that MAC address AAA belongs to 10.1.1.3. He has entered into his table fake information that 10.1.1.1 is having a MAC address of 10.1. Having a MAC address of say BBB. So whenever he wants to send packet to the gateway, he will send it to this guy, because this his fake MAC address is registered, and this fellow will read what you are sending the packet. He will sniff that packet, send it back to the router. Router replies. So he will reply what? He thinks that 10.1.1 is actually having BBB MAC address and not AA. So his information is fake. I made mistake here writing. He is thinking 10.1.1.3 actually is having what? AAA MAC address. So he replies back to him. So he reads the reply also. So this guy thinks this is the router, this guy router thinks this is the user A. All mess up. And this guy knows both of them. This guy knows this fellow also, and this guy. He is an attacker. He knows that 10.1.1.1 is C and 10.1.1.2 is A. So he has given wrong information to this guy also and this guy also. By entering into the ARP process and poisoning that ARP process. That is why many times it is called ARP poisoning also. Clear, all of you? Any question you can ask me? So DHCP spoof attack can be mitigated with the DHCP snooping. IP spoof attack can be mitigated with the IP source guard, and ARP spoofing can be mitigated with the help of dynamic ARP inspection. The mitigation tool is dynamic ARP inspection. To prevent ARP spoofing or poisoning, a switch must ensure, again, DHCP snooping binding table can be used. If this machine try to send, if we try to tell this guy, boss, I am only your gateway, that is 10.1.1. Write down the MAC address, my switch will immediately detects. He is already maintaining a table where he has written that A belongs to MAC address AAAA and IP address is 10.1.1.2 and B is BBBB and his IP address is 10.1.1.3 and C is CCCC and his IP address is 10.1.1. So if B from port say 2, this fellow is on 1 and this fellow is on 3 on some other switch or on the trunk port. So he is receiving this MAC address from the trunk port, or that you call it trusted port, and this is 2 untrusted port. So if B is trying to send information telling his MAC 10.1.1.1 he himself only, and he is trying to give his own MAC address, which will immediately detect, boss, I know 10.1.1.1. His MAC address is not BBB, his MAC address is CCC. How can you pretend? How can you pretend as 10.1.1.1? I know you are my IP address, man. You are 10.1.1.3. How can you reply? That means next time a person come to pay fees, and if this guy sitting on sofa says, I am Alex, somebody will immediately pinpoint, how come you are Alex? I know Alex. The security or the peon or the office boy or the receptionist, how come you are Alex, man? We know Alex. You are not Alex. How can you say that? We have seen Alex. Got it? Or the person also might point it out. How can you be an Alex? So I said, no, I am Alex. I saw his picture on WhatsApp when I chatted with him. He is looking something else, and you are looking something else. That is why when you go to airport with the ticket, no, and you say I am Mr. So and so, written on the ticket, they will immediately ask you for the ID also. They won't believe you because ticket can be lost, no. Somebody lost his ticket and the other fellow can travel with his ticket. Nowadays we have printouts. So the security guy will immediately ask, okay, this is your ticket, come on, show me your ID. And he will try to match the name, the ID and the name. Got it? So ARP spoofing can be mitigated with the help of dynamic ARP. To prevent dynamic ARP prevent these attacks by intercepting and validating all ARP requests and responses. That means the switches are now continuously monitoring those ARP packets also. Switches are now intelligent. They are continuously monitoring those ARP packets. They are checking. Each intercepted ARP reply is verified for valid MAC address to IP address binding before it is forwarded to a PC to update the ARP cache. ARP replies coming from invalid devices are dropped. So if you configure dynamic ARP inspection, and if B try to send fake ARP replies giving fake MAC addresses, it will immediately drop. Dynamic ARP inspection determines the validity of the ARP packet based on the valid MAC address to IP address binding built by the DHCP snooping. See, again DHCP snooping binding table is helpful, because this DHCP snooping binding table carries each and every detail: the IP address, the MAC address, the VLAN ID, the port ID, the lease. So how can a person on that particular switch try to spoof or try to do ARP poisoning when it is already being educated? The switch is already being educated with all the details in its binding table. How can you now fool? See, switches don't do all those things. It is because of the mitigation these switches is maintaining all those stuff. By default they don't do. I remember when I used to teach long back switching, I never thought DHCP spoof attacks in switching. There were no such attacks. These attacks came afterwards, and when the attacks came afterwards, they found out how to mitigate these attacks. Got it? Showing. Every time you see the term untrusted. Untrusted means a port which is not supposed to send any ARP replies, fake ARP replies, the port which is not allowed to send any packet which is having a wrong source, or the port which is not supposed to send any offer messages. So in all three spoof attacks, untrusted term is very important. Untrusted means the switch never trusts that port. It is, that is why you see now nowadays they are telling, if you meet any person, forget he is an unknown person, he is your relative, he is your brother, he is your cousin, he is your friend, anybody you meet, see that you maintain distance. You never know, he might be a carrier. You don't think he is your brother, so he won't be like carrier. He will feel bad if I don't hug him, if I don't shake hand, or if I don't touch him. No, you have to maintain a distance, even if he is your brother, because your brother can also be a carrier. I don't trust, I am not trusting anyone because all these ports are untrusted. Switch is telling me I am not going to trust any port. All the access layer ports, all the access layer switch port is going to be untrusted except for trunk ports. So I hope you understood these spoof attacks. Now many times the spoof can be done with the switches also. DHCP spoofing can be done with the DHCP through DHCP server activity. IP spoofing done by taking the IP address of somebody and attacking. R spoofing done when somebody is trying to do up. Now what is switch spoofing? See, normally you do trunking between two switches. You do trunking between switch and a router. You do trunking between firewall and a router. So, okay. 1 minute. Huh? Okay. So I was telling you in switch spoofing. What is spoofing? So first try to understand that you do trunking between two switch. Trunk links are nothing but one which allows the multiple VLAN traffic to pass. Okay. You also do trunking between switch and the router to send multiple VLAN traffic. Say if you are creating router on a stick, you can do trunking between a switch and a firewall also. So trunking can be done here, trunking can be done here, trunking can be done here. Okay. Now, if you are doing trunking, why actually you need a trunking between a switch and a router, between a switch and a firewall, or between two? Because of its definition. What is that definition? The trunk link can carry multiple VLAN traffic. Now, you never do trunking between switch and a PC because PCs are connected to access layer switches and their ports are actually access ports, not trunk ports. So what is the opposite of access port? Trunk. What is the opposite of trunk? Access port. Access port means one user connected. Trunk means multiple VLAN, one user of one VLAN, or maximum two. If you have an IP phone, you can have two different VLANs connected on a port, voice VLAN and trunk. That means he will allow only two VLAN, voice VLAN and data VLAN. And if you have not configured voice VLAN, he will allow only one VLAN. So access port are basically a port where you connect only one person or one user. Trunk means you are allowing multiple VLAN traffic to move from that port. So somebody is trying to fool the switch by negotiating trunking. You get LAN cards which you can have here on the machine, which is a user attacker. You can buy a LAN card which can negotiate trunking between a switch. Switch can't see who is getting connected. So you must be remembering, if you have done CCNA and switching, that we have DTP, dynamic trunking protocol, on all the Cisco switches. This is the proprietary protocol running on all the switches. And with the help of DTP, if one end is configured for dynamic desirable, other end can be configured for dynamic desirable or dynamic auto and become trunk. So assume that I have purchased one switch, say 2960, okay, some new model switches, and their default negotiation mode is dynamic desirable or dynamic auto. So the hacker will do what? He will put a LAN card and he will negotiate trunking by, if it is DA, then he will make DD on his PC. If it is DD, then both the combination can work. DA and DA will not work because dynamic auto means waiting for the other end to negotiate trunking, invitation. And when you configure DD means DD actually configure or invite the other end, that is DA, to negotiate trunking. Got it? So it is what is the mitigation? Like, see, switches are getting fooled. And why this guy want to make a trunk? Because he want to receive all the VLAN traffic He wants all the VTP updates on this trunk link. His intentions are bad. If he is just a user, then what he will do? If he is just a user, he'll be like member of one particular user only, or one particular VLAN only. But if he is not, what he will do? He will try to negotiate trunking. He knows that if he try to negotiate trunking, he will always get the information of all the other VLANs also. So the main purpose in this attack, that is switch spoof attack, is that he wants to get all the VTP updates on these trunk links, that is VTP advertisement. When you configure trunk, means actually you are allowing all the VTP advertisement to come on that trunk link. So he want to receive all those VTP advertisement, and for that reason he is configuring trunk. His intentions are bad. So how you are going to mitigate this? Simple. You switch off DTP on these switches. By default it is not good. See, when you say show interface so and so, you can see that the clarification, you can see the detailed information. Switch port is enabled. And what is the mode? Dynamic auto. Now see, this is definitely going to create problem. If the other end, if the hacker configure DD, that is dynamic desirable, so that dynamic desirable port will immediately invites the dynamic auto port that come, let's become trunk, and the mode is definitely operational mode is what? Trunk. Why? Because of this automatic dynamic auto or automatic dynamic desirable. So negotiation of trunking is on. This port is now vulnerable for an attack. This port can immediately become trunk, switch port. So in your CCIE routing switching lab earlier, in the enterprise lab also, you will be having these features activated where Cisco wants this feature to be switched off. How? Simple. He will tell you that you configure no switch port on this port. When you configure no switch port, sorry, switch port no negotiate. When you configure switch port no negotiate, what exactly happens? DTP of a particular switch get disabled. When you configure switch port no negotiate, DTP of a particular switch get disabled. That means dynamic auto and dynamic desirable mode is now down. So if it is down, how the hacker will negotiate? The second method is what? You do switch port mode access on all the ports except for genuine trunk ports. Like genuine trunk ports you don't touch. Let the genuine trunk port which are connected to distribution layer remain the trunk, but don't keep the unused port idle. Either you shut down. Third solution. First solution, switch off DTP. Second solution, convert all the ports into access ports. So if you convert all the port into access port, the hacker won't be able to configure trunking then. Because if it is an access port, how you can configure trunk? How you can negotiate trunk? The third solution is, please shut down all your unused port. As an administrator, you can bring them up anytime, no, if you want to use. Okay. So I hope you understood this attack and the mitigation of that attack. How many solutions you can do? You can do 3 solutions. Either you can say switch port mode no negotiate, switch port no negotiate, or you can do what? Shut down all the unused port. So if it is shut down, how the user can go and configure trunk? Or you do what? You convert them into access port. Okay. So I hope you understood DHCP spoofing, IP spoofing, ARP spoofing, switch spoofing, and now the next attack is VLAN hop attack, or you can say double tagging attack. Now what is double tagging attack or VLAN hop attack? When securing VLAN trunk, also consider the potential for an exploit called VLAN hopping. Here an attacker position on one access VLAN and can craft send frame with spoof.1q tags so that the packet payloads ultimately appear on a totally different VLAN. That means every user knows or every technical person knows that on all these switches you have VLAN 1. Everybody knows that. Those who have studied CCNA, those who are working in the industry, everybody knows that VLAN 1 is the default VLAN on all the switches. And everybody knows that in 802.1q tagging, this is called as what? Native VLAN. And then everybody, if you don't know, please pay attention. Everybody should know that VLAN 1 is configured, VLAN 1 is there by default, you cannot delete, modify, remove VLAN 1. Everybody knows that these VLANs are called as what? Native VLANs. Everybody knows that whenever a frame comes with VLAN 1, it is always sent untagged to another switch. It will go like that only, no tagging. Why? Because it is a native VLAN. So suppose, assume that you have a machine here who belongs to VLAN 1 and you have a machine here who also belongs to VLAN 1. So anytime the frame comes in, it will go like that only. Data will be there. So when the switch receives a frame which is not having any tag, he also know that blindly it has to be given to VLAN 1 guys. Because here also the number is same, here also the number is same, here also it is called as what? Native VLAN, here also it is called as what? Native VLAN. So the default rule on all the .1q trunking is what? Whenever a native VLAN comes in, whenever a native VLAN frames comes in, it has to go untagged to another switch. Whenever a switch receives a frame which is untagged, he immediately knows that this is for native VLAN and he forwards it to that native VLAN. But you have a facility, you can also change the native VLAN. You don't want to keep VLAN 1 as native VLAN. So I will do what? I will make VLAN 10 as native. Now you have a machine here who belongs to native VLAN 10, and then you have a machine here who also belongs to native VLAN 10. So if again the frame comes in, it will always go without tag and it will reach. But now the attacker is very smart. What he does? He hides some virus worms or trojans, or he hides some malicious things in the payload, and he want to attack the server. But the server belongs to VLAN 20 and he belongs to VLAN 10, which is native VLAN. So 10 cannot go on 20 until unless inter VLAN routing is done. 10 cannot go to VLAN 20 until and unless inter VLAN routing is done. And he wants to reach VLAN 20. So what he will do? He will write down in front of his frame VLAN 10, which is again a native VLAN. But he will hide VLAN 20 tag. See, he will do this all with some tools, because normally a machine cannot do tagging. Tagging is always done on the switch trunk port. Tagging is always done on the switch trunk port. So this guy will hide VLAN 20 behind VLAN 10. So when switch receives, he immediately find out that VLAN 10 is a native VLAN, man. Who gave this tag? So he will remove switch. This switch will remove this tag. Why? Because VLAN 10, he knows that it is a native VLAN. Always remember, when you configure trunk ports, you have this configuration. What is the configuration? Interface so and so, switch port trunk encapsulation.1q, switch port mode trunk, switch port trunk native VLAN 10. So trunk port knows that native VLAN is 10. So if the trunk port knows that native VLAN 10 is there and the native VLAN 10 cannot go with a tag, so they immediately tear it. When the tag is removed, and the frame is sent to switch B. Switch B receives with a tag of 20. So he thinks this frame belongs to this server who belongs to it. So he removed this because I told you, PCs and servers don't understand tagging or don't understand VLAN. And he sent this payload to this server, and this server is infected now. So what he did double tagging attack. He took the advantage of that decision or that this thing, the methodology. What is that methodology or decision? That whenever you receive a frame which belongs to native VLAN, please send it like that only. Don't tag it, because native VLAN don't need tagging, because it is only same VLAN on both the side. It is the same VLAN on here also and same VLAN there also. So why you need tagging? So hacker took the advantage of the decision that whenever I send a frame to switches with native VLAN, my switch will immediately remove that tag, and so he hided, like he hides that VLAN 20 information behind 10 and he sends. So this fellow removes it. Attacker send a double tag packet. When a catalyst is ready to forward the packet, the first tag is stripped because it is the same as the trunk native VLAN. The packet is received by the catalyst B as the second tag stripped off, and then finally the packet comes to the VLAN 20. So he belongs to 10 and he has now come to 20. How are you going to mitigate this attacks? Simple. You just go and write it down on the trunk. VLAN dot one q tag native. Now why you give this command? Because you don't want this fellow VLAN dot one q tag native. What is the meaning of this command? I am telling my switches why you guys are removing the tags. Send as it is meant. So what happened? Or send all the native VLAN also with tagged. So what will happen if they receive the frame and if they see VLAN 10, which is a native VLAN, they will send it like that only. So if they send it like that only, it will not go to VLAN 20 because they stopped removing the tag. Hacker was using this feature, no? He was looking for this feature that they remove the tag, and so double tagging attack he did. So if you tell your switches that don't remove the tags, man, send as it is. So what will happen? He is sending the frames without removing the tag, all the switches. Second solution is you don't allow your users to know about this tag. Set the native VLAN of a tag. So what you have to do, you do one thing. You need to first change the native VLAN ID. Like everybody knows that VLAN 1 is native VLAN. So the best practice there, in the diagram also you see somebody has changed the native VLAN. But then user came to know about that native VLAN 10. Initially nobody knows that what is the native VLAN. So what is in the next example, in the VLAN hop attack, in this mitigation of VLAN hop attack, what he is doing? He is creating some number and he is telling this is a native VLAN. That means instead of VLAN 1 or VLAN 10, he is making 800 as native VLAN. And then he is going here and making one more provision. He is telling that from now onwards VLAN 800 is going to act as a native VLAN, no problem, telling the switches. And if you see any frame coming with a tag of 800, please don't remove it, first of all. Or you can say don't allow this frame to pass on. That means anytime if you see a frame coming with this native VLAN tag, drop him, don't allow him. But then the question arises that what is the usage of native VLAN? What is the usage? Native VLAN is actually used for sending CDP messages, DTP messages, PIGP messages. So somebody said, then if you are not allowing a frame which is having a tag of 800 to pass on from one switch to another switch, just thinking that this might be a double tag attack, then how come the CDP messages, how come the DTP messages, how come the PAGP or Ether channel protocol messages will go from one end to another, and you are removing them, you are discarding them? So no, there is a special provision that is not given in detail. There is a special provision when you do this for allowing these messages. That means definitely these messages are being passed even if you have configured this command VLAN remove 800. The meaning of this command is allow all the VLANs except VLAN 800, which is a native VLAN. So if you are not allowing this, how the packet, how the frame will go to this VLAN 20 server? It will not go. So I hope you understood what are the solution. The best solution is, instead of doing all those things, you do one thing. You go and tell, next time whenever you receive a frame with a native VLAN tag, see that you don't tear off that native VLAN tag. Send as it is. So if you send as it is, there won't be any attack, because the other fellow will put 10 or 800 and he will send. Let 10 go to 10 and let 800 go to 800. But at least my server in VLAN 20 is saved. Clear? Clear, all of you?
Yes, it's clear.
Very
Yes.
good. So we'll end today here only, because again next time we are going to take some other topics which will take some time. Okay. So I hope you understood what we did today. Any question you can ask me in the next lecture also. What I'll do, I will send you the recordings of both the lectures. Okay. Thank you all of you for listening. Good night. Take care. Have a nice day.
Thank
Thank
you.
you.
Good
Bye.
night.
Bye. Bye. Good night.
Bye. Bye. Bye.